you've watched my Developing Addition Algorithms video, you know that I'm trying to provide you with some suggestions to help students move from the concrete to the vertical algorithm. I want to do the same thing with subtraction today. Again, I'm going to start with 2-digit numbers, but these processes and skills that we're talking about here will apply to 5- and 6-digit numbers. We just want to make sure that students learn a couple of things that are going to help make that transition possible. So we're going to start with one that does not require renaming. So let's subtract 21 from 38. Now, one of the first things that tends to come up every time I do this is when I ask students to represent this, they represent both numbers because they've been adding and they say, well, we put both of them and we put them together. So we have to talk about what subtraction means. Subtraction is taking a part from a whole or finding the difference. And in this circumstance, we're taking a part from the whole. So what should be represented? The 38. So we can represent this using our base 10 blocks. And we know that when we subtract 21, it's actually going to be from this 38. So we're pulling 21 out of this. So we actually don't need any other materials because it's all right here. So that's important that students see that. The other thing is, again, if you watched the other video, talking about where do we start. Because there is no regrouping or renaming, we can start wherever we want. We can pull 10s from 10s. We can pull 1s from 1s. That's just the most important part. Do we understand that we have to subtract from the same place value? So when I do that, I'm going to take 21 and I'm actually going to stack it down here on the bottom, and I'll tell you why in just a second. I could do it with the 10s and I could do it with the 1s, and I ended up with my answer, which is 17. Let's go here and let's see if that's the same thing. When I subtract 1 from 8, I get 7. When I subtract 2 10s from 3 10s, I get 1 10. I got the same answer. I like to have my students come back to here and look at the bottom and see 21 here, 17 here, and if I were to put them back together by counting, would I still have 38? And you could count it by using your place value. So that's kind of a trick that I use to help students make sense of the part, whole. We've got part, and when we put them back together, we get a whole. It didn't matter what place value we started in, and that's something I want you to keep reminding students as we move into mental math and as we subtract greater numbers. So what happens when it does matter? What happens when we need to regroup or rename? If you remember from the previous video, regrouping is the physical action of moving those blocks or place value chips and exchanging them for something of equal value, whereas renaming is what you're doing to the actual digits when you subtract. So let's try another one. Let's do 52 minus 37. Okay, so we're going to go ahead and represent our model up here. And we'll make sure that we have enough. And again, remember, we want to make sure that the students know they are representing the whole. And the whole in this problem is 52. And 37 is going to be part of that whole. So I'm going to find 37 in here somewhere. Just like we did in addition, I asked students to preview the problem. Where might you see something that's going to take a little longer to figure out? So I'm already looking here, and I see 2 1s and I see 7 1s. And if I were to understand that 7 1s are part of this, when I look at these 2 1s, I already see I don't have enough. A lot of times when kids get to something like this, they'll say the answer is 5 because they just switch them. But that shows that they don't understand that 7 is part of 52. So again, it comes back to that. When I'm previewing this problem, I'm seeing I don't have enough. Now again, That's some language I want us to take away from this. I don't have enough. Not that I can't do it. I can. It'll be a negative number if I were to try to subtract just 7 from 2. But I don't have enough ones to subtract 7 ones. But I could check out these 10s here and rename a 10 for some ones that's going to help me out. And that's why we talk to our students once they've previewed and they've seen, hey, this might be an issue, then it might be better to start at the place of least value. So when I start at the place of least value, which happens to be ones here, I look and I say, okay, I'm going to take away 7 ones. Now I actually have kids who are just starting out have to take them and go 1, 2, oh no, I don't have enough. What am I going to do? Like, they really have to do that. So we talk about how can we rename this number to make sense of it. And you can check out the renaming video to get some strategies for that as well. Once I see that it would make sense to take one of these 10s and rename it for 10 ones, I can change my model. But I want to show you something about changing your model. So I'm going to get my 10 ones here. I'm actually going to separate them. So I'm going to separate them by putting my 10 down here below that. And I do that because I want them to see that it was the 10 that they had before. Okay, so I'm making that connection that you took a 10 and you renamed it for 10 ones, and so I actually want it to be separate so that they're making sense of what they did, because now I ask them to go back and count that they still have 52. A lot of times kids will say they don't. So we'll go and we'll count 10, 20, 30, 40, 50, 51, 52, and oh, we still have 52. It just looks different. Again, check out that renaming video because that was a skill that was really eye-opening to me with working with second graders to see that they thought that was a different number. So now that we've done that, let's see how our problem changes. What we ended up doing was we said instead of having 5 10s, we were going to take one of those 10s and rename them for some ones. So I ended up with 4 10s, which matches here. And I ended up with 10 and 2 more. Now that's an issue too. A lot of kids, because they're just getting into that idea of 10, they'll say the ones now have 10 ones instead of 12. So some people even would put 10 plus 2 to help kids remember the 10 and the 2, or you could just put a 12 up there. Whatever works. Now we can do our subtraction because we have enough ones to subtract, right? And we have enough 10s to subtract. Again, like you saw in the first problem, we can pull these down here so that we can still check our answer, and we can just turn them so that way they are still seeing that this was a part and this was a part, and when we put them back together we have 52. So just a few little takeaways. Being very careful that when you subtract you're representing the whole and that you pull the part and make it separate. When you find that you have to regroup or rename, you obviously want to start in the place of least value, but if you don't have to do that, it's okay to start wherever makes sense. As students are recording this, be sure to use the language of 10s or hundreds or whatever that may be and reference it back to the model each time. I hope these strategies are helpful. Again, apply them to all different types of numbers, whether subtracting decimals, 6-digit, 5-digit numbers, but you will see a pattern as students make sense of these, and go ahead and use that grid paper to help them align their digits.